Hey Dr. Elaine, this is Blair. The standards are Newton's second law. This question has 4 parts to it, so I'm going to try my best to be under 5 minutes. Okay, so here's my free body diagram. Here's the normal force. Gravity, supposed to be the same magnitude. Here's the kinetic friction, because she's sliding against the floor. Here's the force that she's pulling with at an angle. This is supposed to be a little bit less than this force. So anyway, this is what I converted it to, just to show you that the force that she's pulling with has two components, an X and a Y component. No, this is not an angle. Okay, so part A, what I did was I wrote down this equation first, and the only thing I really added to it was all the Y components. This is all the Y components. So in the force that she pulls with, and of course gravity, I manipulated it to get N by itself, and this is how it looks. So, and they want to know the force on the suitcase. So M, 36 kilograms, G, the constant, 9.8, subtracted by the force that she pulls with, 65 newtons, multiplied by the sine of 40, and this is what I get, and that's the answer. That's what she pulls with. Now for B, they just want to know about the kinetic friction. So this is the equation for kinetic friction, and they gave us the coefficient of kinetic friction in part B. This N is what I just solved for, so we just multiply them, and this is the answer. Okay, now for C, they're going to want to know about acceleration. Okay, and this is going to be all the X components. So the only X components we have is the force that she pulls with, which is one X component, and the friction. So we'll plug that in, and we end up with 9.36 newtons. Now we would have to divide by 36 kilograms, because this is the this is what I would plug in and manipulate by to find the acceleration. Okay, because you have to deal with the X components first before we can divide all the X forces by the mass. Okay, and once you do that, this is what I get, 0.26 meters per second squared. And part D, I believe it wants to know about the starting from rest. So part D, okay, so all I did was I wrote down the acceleration equation, change of V over change of T, and I manipulated it first to get the change of V by itself, and then change of T by itself. So once I get change of T by itself, I know that the change of the velocity is just Vf minus Vi. So the final velocity happens to be 0.5 meters per second, and she starts at rest. So it's 0.5 minus 0. So that's 0.5 divided by the acceleration with which we just got. Divide that. The meters cancel out. 2 of the seconds cancel out because you got second squared right here. And you end up with 2 seconds.